Welcome everyone to AURI Connect's Webinar Wednesday, part of AURI Connect's recurring online series, featuring updates on the work that AURI is doing to foster long-term economic benefit for Minnesota through value-added agricultural products. I'm Dan Scogan, your host on Webinar Wednesdays. The AURI Connects program is hosted by the Agricultural Utilization Research Institute in Minnesota, with sponsorships from Bremer Bank and Avisen Legal. This program aims to actively engage all participants in the food and ag industry to improve the competitiveness of producers, businesses, and entrepreneurs through the ongoing purposeful connection of resources and partners along the value chain, and to increase knowledge of opportunities, technologies, and trends. The Connects program meets the AURI mission to accelerate the expansion of the agricultural economy by empowering expanded uses and markets of agriculturally derived products. Remember, this event is being recorded and archived and can be found at auri.org. You will be muted during our presentations, but you can send us your written questions through the Q&A portal on your screen. Today, we will continue with part 4 of our 4-part series on climate change opportunities for value-added agricultural businesses. Today's discussion will focus on climate change opportunities for nitrogen, as we learn about important and relevant developments in nitrogen use with limited environmental impacts. Joining me today will be several presenters, starting with Brad Matuska. Brad is AURI's Business Development Director of Biomass Feedstocks, with a focus on producers and industry to develop and execute projects and initiatives resulting in the commercialization of new value-added products benefiting Minnesota agricultural biomass feedstocks, including manure, crop residues, food waste, and other co-products. Brad co-founded an organics recycling business called Mississippi Topsoils back in 1998. That commercialized value-added products made from the wastewater treatment biosolids of a poultry producer. We'll hear from David Ripplinger. He'll present. David is an associate professor of extension bioproducts, bioengineer economist at North Dakota State University. He holds a PhD from NDSU in transportation and logistics. We'll also hear today from Dr. Anton Kreimer. Dr. Kreimer is a senior associate in RMI's Climate Aligned Industries program, supporting efforts to decarbonize hard-to-abate sectors with a focus on fertilizer production. He works on the Green Hydrogen Catapult, a joint initiative between RMI and the United Nations High-Level Champions for Global Climate Action, developing pathways to accelerate green hydrogen adoption. He analyzes ammonia applications internationally and in the United States. Next will be Miguel Olivares, the Technical Service Provider Program Coordinator of the Central United States region for USDA Natural Resources Conservation Services, or NRCS. Miguel started working for NRCS back in 2014. During this time with NRCS, Miguel has served in many different capacities at the field, area, and state office level. In May of 2023, he joined the Technical Service Providers branch as the Regional TSP Coordinator for the Central Region, and now spends his time assisting TSPs with the certification process. We also plan to hear from Mike Reese, who will present today, and Mike has been the Renewable Energy Director at the University of Minnesota West Central Research and Outreach Center in Morris since 2001. He's been overseeing the development of the renewable energy program at Morris and has participated as principal investigator or project manager on more than $18 million worth of research and demonstration projects, including wind energy, biomass gasification, renewable hydrogen and ammonia, and solar energy systems. He is leading the Renewable Energy Program's new strategy to reduce fossil energy consumption in agricultural production systems through incorporating renewable and efficient energy technologies. Reese also assumed the role as Director of Operations in August of 2022. And then we welcome Lori Marco, JD. She has practiced law for 25 years, 13 of which were a general counsel to a Fortune 300 protein company. She now leads sustainability and downstream engagement for Landis, the largest agricultural cooperative in Iowa. She collaborates across the supply chain, developing solutions for positive impacts for farmers and the planet. And since this is the last of a 4-part series, and some of you have not had the opportunity to participate in all or part of the first 3, We will start today by having Brad Matuska frame today's conversation and put today's discussion into context as it relates to the other three parts of this series. Brad, welcome to AURI Connect's Webinar Wednesday.
We're going to be talking about the opportunities of climate change as it specifically relates to nitrogen. So nitrogen, as we all know, is an essential to soil and plant health and is a key ingredient in fertilizers. And fertilizers are indispensable in sustaining high agricultural productivity. However, careful nitrogen management is critical to preserving clean air and water. To that end, our panel of experts will discuss a variety of topics related to nitrogen, which include these four items. The first is the pros and cons of fertilizers on the market and in development. Number two, the effective processing and management practices to reduce environmental impacts, including runoff and inconsistent yields. Number three, the developments in the decarbonization of synthetic nitrogen. And last, how recycling nitrogen from organic waste offers a sustainable alternative that can reduce reliance on synthetic fertilizers. So with that, I'll hand it off to David Ripplinger to get us started.
Great, thanks, Brad. Pleasure to be with everybody today. As Brad mentioned, I think we're all familiar with the role that nitrogen fertilizer plays in crop production. It truly is indispensable. If you want to have chlorophyll and have energy from the sun, you need to have nitrogen present for that to occur. And of course, also as Brad mentioned, that is of increasing, it's of continual importance because we have this demand for biomass, and most evident for that is food. And so here's a slide I oftentimes show, and I think it's important to note that about half of the people today receive their calories because we use synthetic fertilizer. And so we have this this foundation, this requirement for fertilizer, and yet it comes with costs. And obviously, today we'll be talking about those related to greenhouse gas emissions and climate and solutions for that. But it's important to keep in mind the why we have interest and demand in nitrogen fertilizer. Yeah, and so here's just a chart. It's actually made by Minnesota Department of Agriculture that shows Minnesota nitrogen fertilizer sales recently. Different forms of nitrogen fertilizer are present in and broken out for urea and anhydrous. So urea solid fertilizer is in Minnesota and in many states the primary form of nitrogen fertilizer used by farmers in combination with anhydrous, and that's usually depending on availability as well as how it fits within farm operations. And then we have various solutions. So this would be like an AN/UAN solution, so liquid fertilizer. And then there's this other sources. There's many fertilizer used by commercial producers that fit in different ways. Really kind of exhaustive list. The biggest thing to understand, and you can see it somewhat within this slide, but slides for the United States and elsewhere, is we've had this tremendous increase in the use of nitrogen fertilizer. Just to reiterate its importance in this time in terms of cost. So this would be the financial cost of fertilizer. So it happens to be that middle $217 per acre cost that University of Minnesota Extension estimates it costs a farmer in southern Minnesota to produce corn. So it's a substantial cost, basically typically on par with rent as the primary cost. And again, it's there because it provides that ability to produce biomass. And so with corn, we have so much material being produced, so much being harvested, that you need large amounts of nitrogen to meet that requirement. Many of you may be familiar, nitrogen fertilizer is the primary source of greenhouse gas emissions in crop production, looking broadly. And that comes from a few different places. Folks who are unfamiliar might first think it's coming primarily from manufacturing, or the amount of diesel fuel it takes to move or to power the tractor, but really the biggest source is nitrous oxide emissions in the field. So if you fail to get the nitrogen into the plant and it becomes absorbed into the atmosphere, that's a very, very potent greenhouse gas. And as I mentioned, again, the number one source of greenhouse gas emissions, or in terms of impact of greenhouse gas emission on the environment. Just to look a little bit at decarbonizing is really exciting to be part of this panel. There's a lot of different things that can, are, and will be done in this space, and you have some of the innovators here today. I'll always start with, even if there was no push, nothing being done, farmers are ever more productive from year to year. We can see this in trend line yield and different measures for productive efficiency. So knowing that, having this expectation that we're going to have an increased production over time, that would essentially, it would reduce the carbon footprint of crops. And that's great. But really, it's not enough, especially when you think about how big a contributor nitrogen fertilizer is to greenhouse gas emissions, globally. Looking more aggressively, and we'll talk about a few of these things today, going back into production, a lot can and is being done to decarbonize fertilizer production, and a couple of exciting parts with that. You can have carbon capture and either use or storage at an existing natural gas to ammonia fertilizer plant, which is great. Maybe more exciting, especially looking at Minnesota specifically, is the use of renewable energy to provide the energy to run electrolyzers and the like to produce hydrogen and then ultimately ammonia. And then finally, you can be more aggressive, more on the farm side, although it's kind of an enabling technology, is changing nutrient management. And this could be changing the actual fertilizer used, which I think we're very much going to see in short order. It might not be, it could be where a farmer doesn't change anything, where the physical product is the same, except for the story behind it, because it's been made with low carbon processes. And so that's really exciting. And then, as was mentioned earlier too, the use of some natural products, working that into the system, using something from a digester like struvite is really, really interesting. And it actually goes back to the beginning too of thinking about, we want nitrogen to be available to the plant. And some of those types of fertilizers are more accessible. Finally, just talking about incentives, there's a lot going on right now, both in terms of regulation and market activities. Biofuels are a big part of that. So we see California's low carbon fuel standard playing a leading role. One thing we haven't hit yet, primarily United States, is climate disclosure laws. There's a lot of interest, if not a requirement, for the reporting of greenhouse gas emissions for products. We have a somewhat exciting new tax policy. That's kind of an odd thing to say. With the clean fuel production credit, which is also referred to as 45Z. That is expected to incentivize farm level practices, which would extend to low carbon fuels or efficient nutrient management, being the more common term. Been a lot of talk recently about carbon offset contracts, where farmers would change practices. That could include making changes to the fertilizer they buy. And again, that would be a change that they make, and another company would pay for the credit to offset their ongoing emissions. And then finally, we're seeing the emergence of market-driven premiums, where in the absence of government intervention, businesses do find that it's worth it to their business to pay a premium for lower carbon crop. And again, one of the big legs of that is the carbon footprint of the fertilizer they use. And those were my remarks, so I'll hand it over to Anton.
Thank you. And thank you for inviting me today. I'm working for Rocky Mountain Institute, which is also known as RMI. It is a non-partisan organization. It means that we support solutions which benefit everyone, both society and economy. And my team at RMI is focusing on green hydrogen and ammonia technologies. We collaborate both with policymakers and industry players, such as OEMs and project developers. And in our work, we aim to identify main roadblocks for market development and estimate potential of new emerging technologies, also improving awareness about them. Last year, our team was developing a roadmap for distributed ammonia production in the state of Minnesota, and we published our report, our roadmap, in June. We concluded that distributed ammonia production, also known as DGA, is already cost competitive today in comparison with centralized gray ammonia production. And also it can bring significant benefits to the state of Minnesota. So why exactly DGA, and why did we consider Minnesota? DGA means that fertilizers and anhydrous ammonia can be produced by a small-scale modular system, which uses renewable energy, nitrogen, and green hydrogen produced by water electrolyzers. There's a list of available technologies which allow small-scale and modular systems that can be flexible in their operation, and they work pretty well with intermittent renewable energy resources, for example, solar or wind parks. And Minnesota was chosen for three main reasons. The first one is that Minnesota is a noticeable consumer of fertilizers. And at the same time, there is no local production of fertilizers in the state. Means that farmers have to deliver to bring fertilizers from other locations. And it means that the final price that they pay for fertilizers is further inflated by these delivery costs. And the third reason is that we see that there is already a certain momentum in the policy field in Minnesota, as local policymakers, pretty aware of this above mentioned factors, are developing new solutions and mechanisms to facilitate adoption of local fertilizer production in the state. When we speak about potential of DGA, one of the main and obvious benefits that it can bring is price stability. Because when we speak about, in comparison with about gray ammonia production, which uses natural gas as the main feedstock, we obviously see fluctuation of the natural gas price. And as a result, extreme fluctuation of fertilizer price in the market. As we all seen after a Russian invasion in Ukraine, this abrupt changes in the market led to extreme prices of fertilizers, and price of ammonia reached $1,600 per ton. And even today, because ammonia is a globally traded commodity and international prices are interlinked and connected, even today when natural price is relatively cheap, we still don't see this pre-war price ranges for price of ammonia. The second benefit is that when we speak about centralized production, natural gas-derived gray ammonia, we see a centralized model, and the produced ammonia has to be transported to the final customer, to the farmer. And often this transportation chain can be rather long, and it can include different types of transportation, different modes of transportation, and naturally it becomes exposed to different types of risks, so it cannot be resilient. And also, when we speak about weather conditions or seasonality, we can see that under certain scenarios, this transportation can be extremely expensive as well. So local production is price stable, and also the delivery is simple, cheap, and doesn't bring any risks. So that's also clear benefit of the DGA model of ammonia production. But in general, when we speak about new technology, new pathway, we have to obviously address the topic of price. So what's the cost of ammonia production using DGA? One of the main elements here is the cost of energy, which is used, renewable energy, which is used for ammonia production. And when we consider the state of Minnesota, we see that favorable wind conditions can make production of ammonia quite competitive with centralized gray ammonia production. And also another aspect here is that a as the system uses renewable energy instead of gas, then this price of ammonia production is stable and doesn't fluctuate. Another important aspect here when we speak about cost of production is the cost of the system itself. Today, we already see projects that are being commissioned, and we expect that new technologies, new solutions, and alternatives will become available in the market. And naturally, we anticipate that in the coming years, the capital cost of DJ systems will drop. It all means that green ammonia produced by these modular systems will be more and more cost competitive with gray ammonia in the market. Speaking about co-benefits that DJ can bring, we can say that as the system uses renewable energy, ammonia projects will bring investments in local energy infrastructure. And also it will require trained workforce, meaning that ammonia projects and DJ raise opportunities for jobs in rural areas. Besides these possibilities and benefits of DJ, we should also address action points. So what can be done in the state of Minnesota to facilitate adoption of this technology? And together with our industry partners, we identified main roadblocks and main barriers that limit adoption of DGA. One of the action points that they listed is creation of a certification scheme which will differentiate gray and green ammonia in the market. They also highlighted that permitting process right now is quite expensive and can be extremely long, so it's also a limiting factor. Moreover, our project developers and partners told us that access to low-cost capital would be also essential to move these projects forward. So overall, summing all these benefits and challenges, I can say that DGA can be already an economically feasible solution today in the market and quite competitive with gray ammonia production. And it clearly brings a lot of benefits for farmers and the state of Minnesota and local economy. Thank you, and I'll pass it over to Miguel.
Mike Reese, if you're ready to go, I think we're going to let Miguel try to figure out his issues, and we'll go to you and hear your part of the presentation.
Okay, great. All right. So thank you. I'm Mike Reese, Renewable Energy Director at the University of Minnesota West Central Research and Outreach Center. Good afternoon, everyone. Ray, can you put my slides up for me, please? Okay. We've worked in green ammonia for the last 20 years, conducting research on this. We had the first wind to ammonia pilot plant back in 2013. I think there's a lot of opportunities and for Minnesota and beyond in pursuing this. Next slide, please. So I'd like to quickly acknowledge some of our funding organizations, State of Minnesota, University of Minnesota, as well as Department of Energy ARP-E program. Next slide, please. You've already seen this slide from Dr. Ripplinger. I think it's still important to show that nitrogen fertilizer sales in Minnesota are significant, close to anywhere from $500 million to $1 billion annually in sales. You can see that urea is increasing in consumption and ammonia is decreasing in consumption, but still significant. And putting this in perspective, Minnesota ranks 4th nationwide in corn production, has significant small grain production, which all utilize nitrogen fertilizer. Next slide, please. I believe it's an elegant solution for Minnesota when you can take wind or solar energy, use water to electrolyze or to produce hydrogen, electrolyze water, produce hydrogen, pull nitrogen from the air and put them together to form nitrogen fertilizer. So the steps that we use at our pilot plant in Morris are listed above. Electrolyze water, separate nitrogen from air. We run it through the Haber-Bosch process under high pressure, high temperature. And then the next thing that we're interested in is in using CO2 from bioethanol fermentation to produce urea, and that's creates a circular model where you're putting the urea in the soil. The CO2 is released. The plants uptake the CO2. The corn grain is brought to the ethanol plant. The ethanol uh, during fermentation, the CO2 is released, producing both ethanol and CO2, and then you can capture that CO2 again and produce urea. And urea is nice and in that it's easily stored and transported. Next slide, please. So for those of you not familiar with urea, it's a granular product. You can bring it out to the field in the trucks that are shown on the upper right. You can spread it quickly in the field, or you can pull a trailer behind or spreader behind a tractor, and it's inexpensive storage facilities are required for this. Next slide, please. I do believe that green ammonia is a drop-in replacement. It's transformational to be able to do this. If you look at other uh, ideas or schemes to decarbonize agriculture, many of them involve different crops, uh, different equipment, different developing markets that aren't necessarily in place right now. Uh, and again, green ammonia is a drop-in replacement. It's the same as conventional ammonia. Uh, if you look at the pie chart that I've shown there, this was research done by my colleague Dr. Joel Tellickson back in 2016. It shows the fossil energy consumption in the production of corn at our facility. About 36% of the uh, fossil energy footprint is attributed to nitrogen fertilizer. 42% is grain drying. Since we are a little higher in the or further north in the corn belts, we use more natural gas and propane in drying. Then about 14% for field work. Uh, One thing I want to point out, and I'll talk a little bit about here later, is that we can potentially reduce fossil energy footprint in corn production just using green ammonia. So not only using it for fertilizer, but also using it for grain drying as well as for field work. And we've done both of those here at the West Central Research and Outreach Center in Morris, our research farm. And I think this is important to show because there aren't too many models and too many ideas and concepts that can get to that level that quickly. So next slide, please. I think this is perhaps the most important slide. It was previously talked that green ammonia is cost competitive right now with conventional ammonia. I think that's true in many respects. If you look at the black line, uh, hopefully all of you can see colors, but the black wavy line is the retail price for ammonia over the last 15 years, approximately 10 years is shown here. Uh, what you notice is it's highly volatile, and so that's a really important factor when you're talking about green ammonia versus conventional ammonia. Green ammonia is not volatile. If you're using wind or solar, you're usually locking in those prices for 20 to 30 years. The blue line represents what we can do with technology today. And so again, it's cost competitive today, and most of the time, it's those dips that we're concerned about. If we're having farmer groups, for example, produce green ammonia, we need to be able to bridge those gaps. If you look at what technology improvements do or are expected to do over the next 10 years, that's the green line. You can see that we've have overcome a lot of those valleys in the price, but we don't come all the way. And so that's one thing I wanted to leave with you today. Just kind of question whether it will continue to move forward. But the Inflation Reduction Act through the 45V provided $3 per kilogram hydrogen credit for low carbon intensity hydrogen. And if you look at the impact on ammonia production costs, that's $529 per metric ton of, the hydrogen production incentive for the first 10 years of production. Now, these plants typically will run for 20 years. And so, if you're going to levelize that cost over that 20-year period of time, you see that it represents about $356 per metric ton. And so, the blue dotted line is uh, the first in today with the IRA, and the green dotted line is in 10 years, where the expected technology and manufacturing capacity will bring us. And this is done by my colleagues, Dr. Matt Pallas and Professor Perdomus Steatides at the University of Minnesota. Next slide, please. So University of Minnesota is a world leader in this field of green ammonia. We had the first wind to ammonia pilot plant in the world. We have done grain drying with colleagues in mechanical engineering with Professor Will Northrup. Same group also demonstrated a ammonia fuel tractor at a facility. It was brought up that we have significant assets in the state of Minnesota for ammonia. That includes significant storage, picturing a CF storage facility, 60,000 metric ton storage facility. So we have a lot of the pieces in place to switch to a green ammonia industry, a green nitrogen fertilizer industry. And then we're also developing systems that can produce electricity from or using green ammonia. I think these technologies are important. They may not be the core technologies, for example, grain drying, but you can imagine if you're trying to hit a carbon intensity score such as ethanol, uh, and to be able to produce SAF, for example, and get down to a 30 or get below a 30, you can meter in green ammonia, for example, into your drying systems or your boilers to lower that carbon intensity. So that's the intent. There are some issues that we're working on regarding NOx and N2O emissions, but overall, those we believe those can be overcome in a short order. Next slide, please. So the next generation ammonia production system is currently under design. Now, this is part of an ARPA-E, U.S. Department of Energy ARPA-E refill program. It's a roughly $20 million effort that involves our primary lead investigator and Research Triangle Institute, Casale, which is a legacy ammonia technology engineering firm, and then others such as Nell, GE Research, Shell, Xcel Energy, Great River Energy, Otter Tail Power. A lot of Minnesota utilities are involved. And what we're demonstrating with this is the ability to quickly ramp up and down ammonia production, which is extremely important when it comes to the cost of electrolyzers and the cost of hydrogen storage, especially hydrogen storage. If you're able to ramp up and down your reactor quickly, and in this case, it'll be a ramp of 1 hour from 100% down to 10%, and another hour back to 100%, that will greatly reduce the cost of the overall production system. Next slide, please. So we envision green ammonia going beyond nitrogen fertilizer, crossing sectors and coupling those sectors together. So I think ammonia green ammonia does have a transformative impact. It enables the hydrogen economy. It allows us to move into other areas using green ammonia for thermal energy, for energy storage, for producing other forms of fertilizers, urea, ammonium nitrate, things of that nature, but also enables the hydrogen economy. So we're able to mass manufacture electrolyzers, get that industry to a point where it's cost competitive, so we can go into sustainable aviation fuel, green iron, and other applications. So thank you very much. Next slide. Okay.
So Miguel, if you're able, take yourself off mute and please continue your presentation.
Yeah, thank you, Dan. Can you hear me?
Yes.
Okay. Yeah. Good afternoon, everyone. I'll start it, stating that I'm joining this webinar today just to provide an overview of the Technical Service Providers Program. I was saying that, we all understand the implications that nitrogen can have on the environment and climate change. So that's why NRCS is helping landowners and producers with site-specific management and implementation plans in order to improve nutrient use efficiencies and reduce nutrients losses in surface water, erosion, and or air emissions. So Dan, if you can advance that slide for me, please. All right, so the TSP program is broken into regions. Like I say, I'm the Central Region Coordinator. We also have a couple of regional coordinators covering the other 3 regions. Stacy Bradshaw, she covers Southeast and West regions, and then Peter Hogland covers the Northeast region. This slide right here has our contact information, as well as the TSP National Program Manager, Charlotte Brewsters. So, feel free to reach out to us. Next slide, please. So what is a certified technical service provider? As you can see here, certified TSP can be an individual, an entity, which can include businesses, nonprofit organizations, or similar organizations, American Indian tribes, or public agency who is certified by NRCS and on the approved list to provide technical services to eligible participants. Also, TSPs can provide technical services to eligible participants once certified by NRCS through conservation planning. They can also do outreach and training and can provide assistance with the design and implementation of NRCS conservation practices. Next slide, please. So once you become a TSP, who are your customers? So your main customers, once certified by NRCS, in place on the approved list of, to provide technical services, main customers will be producers, landowners in or American Indian tribes participating in the USDA Farm Bill programs. But TSPs can also be selected by, nonprofit organizations, public agencies, and NRCS. And this is normally done through, special agreements or different kinds of contracts. Next slide, please. So now let's talk real quick about TSP opportunities. As a TSP, you can provide the following technical services. You can develop conservation planning activities. You can develop design and implementation activity plans. Can develop conservation, evaluation, and monitoring activities, and can also assist, with the implementation of NRCS conservation practice. And these may include designing, providing assistance with the implementation of the conservation practice or assisting with the checkout of the practice. Next slide, please. So what are the CPA, ZIs, and the CMAs? CPA, ZIs, and CMAs are equipped financial assistance opportunities for participants to hire a technical service provider or a qualified individual to provide conservation planning, develop practice design or develop implementation instructions. And, the TSP can also do some monitoring or can evaluate, conservation measures that are applied to the land. So here are some of the planning activities that the TSPs can develop for landowners and producers to help them meet their conservation goals when it comes to, nutrient management and things of that nature. I'm not going to cover these in details. These are just a few that I wanted to highlight because of today's topic. But we have many more. So if you feel like you have the qualifications or have the expertise to provide these technical services, please reach out and, we can have the conversation. All right, so I also wanted to share some, resources with y'all. So this right here is the TSP program website. This is pretty much a one-stop shop for all things related to the TSP program. This site has information and resources for landowners and TSPs. We do our very best to keep this website updated, just to let you know about upcoming trainings, important announcements, system updates, or maintenance and things of that nature. On this website, we also have step-by-step instructions on how to become a TSP that will guide you through the process. But no worries, we're here to work on this process with you. Feel free to reach out to any of us anytime. And then we have an additional resources section at the very end of this site, at the very bottom of this webpage, where you will find NRCS registry user guides. You will find like training videos, policy documents, state-specific training models, and other important resources.
Let's turn our attention to Lori Marco. Good afternoon, Lori.
Good afternoon. So just a short intro to Landis. Landis is a large agricultural cooperative headquartered in Des Moines. We are 5,500 farmer owners, mostly corn and soybeans. And we are a very progressive cooperative. We're committed to sustainability, and we invest in new technologies and provide space at our headquarters to introduce farmers to those technologies. Recently, we have been able to offer farmers a chance to purchase group health insurance. We are developing a technology platform that farmers can use to store all the data about their farms and practices. This is everything from the public record to their machine data, so farmers can use the power of that data to make decisions about their farms. And we recently launched Conduit. Conduit is a new tech-heavy business that provides farmers with a fintech and an e-commerce platform. As part of our pursuit of technology and sustainability, we have also formed a partnership with Talus Renewables. Talus produces small modular green ammonia systems and installs them at or near their point of use. This takes links out of the supply chain and reduces the need for transportation and all of the carbon impacts that are related to shipping and distribution. In their first deployment, Talus 1, this was installed at a Kenya nut company farm in Kenya, in an area in which fertilizer is necessary, but very difficult to get on site. It produces 1 ton of green ammonia per day, and it is used entirely on site and is powered by its own solar array. The second Dallas deployment is in the world is at the Landis Ag Retail Manufacturing and Distribution Center in Boone, Iowa. This is one photo of it. It is completed and has produced green ammonia. It will be fully up and running by the end of this year. The electricity is provided by an on-site solar array, and this is a proof of concept project, and it will produce 1 ton of green ammonia per day, which Landis will be using internally in our own crop production. Here's another photo of the facility. Our next facility will be located in Eagle Grove, Iowa. This will be a commercial size 10 tons per day facility. Eventually, we plan to have up to 3 of these 10-ton units on this site. This unit will run on the rural electricity grid, and we will purchase renewable energy credits to offset that use. This is a revenue source for the Rural Electric Association, and we can adjust the facility to peak demand so that we will idle the unit during peak demand and run it only off peak. And this reduces energy costs for all the subscribers in the RA. Advance that slide to the next photo. And we have one additional site planned. This will be another 10-ton per day facility. This unit will be near one of our larger farmer members, and we expect that single farm will make up the majority of the offtake for that unit. Our intention is to deploy these green ammonia units across our Landis footprint, and we have identified at this point about 60 sites for construction. We will integrate our green ammonia offerings into our larger suite of products and programs with environmental and economic sustainability impacts that bring value to farmers. And we have a whole suite of environmentally friendly ag products, and we promote sustainability to and for our farmers. We've lobbied for flexibility in the 45Z rules and in the GREET model to consider ag products that have these reduced CI scores, which, unlike the 45B rules, which went with an all or nothing approach to on-farm practices, we really believe that flexibility sponsors innovation in this area. And we also work with CPGs, biofuel plants, and other sponsors of programs that support reduction of carbon intensity or scope 3 emissions. And we think green ammonia will be a big part of helping us achieve those reductions. Brad, I'll send it back to you.
Great, thanks, Lori. That's fantastic work. Really very interesting. I just wanted to introduce a little bit about the work that AURI is doing along these lines, and it's, we'll dovetail a little bit into the question and answer as well. And I couldn't help to notice some of the questions that were coming in and how it relates to the work that we're doing here at AURI. And we're looking at nitrogen as an asset through the lens of utilizing biogenic sources of nitrogen. So, for example, using manures and organic wastes and the organic portion of the waste stream or food processing waste, which isn't anything new. I mean, manure has been applied for, forever. But the lens that we're looking at it is to capture biogas coming off of those materials using an age-old technology called anaerobic digestion. And but the end of the story is not just the biogas, which can go into electricity production or renewable natural gas or other energy source products, but we're focusing a lot on the digestate, which is the material that's resulting after the anaerobic digestion process. And so essentially it has the same nutrient components as the raw manure or the organic feedstocks going into that system, but it's in a different form. And so I think some of the questions that are coming in are talking about, okay, yeah, we use a lot of nitrogen in the form of ammonia, but we're not doing a very good job at it because we have some nitrogen in groundwater and our practices, need to be constantly adjusted to manage, the most efficient use of these products. And I think that, David touched on that as well as Mike, and looking at the efficiency and the best management practices in utilizing these materials. And so what's interesting about digestate is that it makes the nitrogen available in a form that the plant can use right away. And so if that digestate is applied at agronomic rates, it directly results in less of a need for synthetic sources of nitrogen. And so, but the long and short of all of this, and I think, Dan, as we get into some of these questions, is that it really depends on the efficient use of operators, and it has a lot of variables that are involved with the application and the efficient use of nitrogen from these plants. And so that's a little bit of an introduction as to the work that AURI is doing. And so, Dan, did you want to lead into some questions that we're getting from some of our participants?
Yeah, let's do that, because we're getting a little bit of a pushback on how green it really is, and I think it's important to address those. And I think this question came in when Anton was speaking, but anybody on our panel today can take a grab at it. Are any perceived roadblocks environmental organizations and their concerns themselves choosing Minnesota as a consumer of fertilizer for ag is correct, but it's also a waster, as evidenced by poor water quality reported by state agencies and the need for EPA to step in for health of its residents? It seems green ammonia isn't really that green, or isn't so green. Is that a fair question?
I can take that
Sure.
question if you wouldn't mind, Dan.
Sure.
Yeah, the comments are correct. Nitrogen fertilizer, overuse of nitrogen fertilizer can be have an environmental impact. We don't want babies developing blue baby syndrome and having health consequences. There's sensitive soil areas, and our state agencies and legislators are taking action to address those. University of Minnesota is developing the guidelines for proper amount of nitrogen fertilizer to apply without developing waste, taking action to limit the amount of runoff and all those things. But it does come down to the point where you do have a grand challenge that we need to feed the world, and we do need to feed the world and billions of people, but also protect the environment. And so there's always trade-offs. I still think that we can make progress in reducing the greenhouse gas emissions associated with nitrogen fertilizer, the current nitrogen fertilizer process, and we can also develop better economies for rural Minnesota as well. So I think it comes back to there are no perfect answers, no perfect solutions, but this comes a long way to addressing a lot of the issues.
And
So yeah, and I'd add too, if
Yep,
it's
go
okay,
ahead.
Dan. Yeah, I mean, I would add too, nitrogen fertilizer, all fertilizer comes with a cost. So, farmers in general are trying to apply it economically. And that doesn't necessarily mean we avoid other environmental issues. But for the most part, they're looking to make use of the money that they spend, and so that addresses it to some extent.
David, while I have you on the screen, I was going to ask you if genetics are going to play a role in reducing our use of nitrogen. I've read an article on this short corn and some of those things. Is that going to be helpful in the end game?
Yeah, I mean, if you look, there's a lot of work being done on a lot of different species. You know, nitrogen use efficiency, water use efficiency are critical. I would say just more broadly that there are going to be technological innovations, some that we can see already today that are going to allow us to use nitrogen more efficiently, which is, you know, the core of what we're talking about today. And again, is that going to be in the plant and the genetics? Possibly, but it's going to be across the board. It's going to be technology. It's going to be farmers' decisions. It's going to be other things that happen in the field. And so, you know, I see for a number of reasons why we will get better at this. And again, you know, we're looking at ways to decarbonize. You know, this conversation is about decarbonizing the material going into the field, but there's a lot of work being done, and a lot of it just naturally so, to make sure that we're making the best use of that end. And again, I mean, one of the big things is we want to get that end of the plant. You know, we just don't want to apply it to the field. We want it to get to the plant and have material.
And Anton, I saw you nodding in agreement during part of that response. Anything you want to add to that?
Thank you. No, I think that it's all been pretty well summarized, that even if we speak from the science side of things, that as Brett formulated, when we speak about losses and deficiency of fertilizer application, then we should recognize that a lot of different factors are involved that are not typically in power of farmers to control. When we speak about weather conditions, when we speak about temperature or moisture, just essential things that we cannot affect. But yeah,
Kind of a follow-up question to that first one. They say it appears the steps ignore a large GHG emission in the origin life cycle that the origin life cycle produces with a byproduct called green. You can't remove the prior by adding something at the end. This another comment about whether or not we really have a green product, I guess.
You know, I mean, I'll jump in. I mean, I do life cycle assessments for all sorts of things. If someone wants to critique the measurement of any product, they can go for it. But for the most part, that work is pretty sound, and it's all transparent. You know, everything that anyone does, you know, the data is known, the math is known, and so, you know, I don't see anything hidden in conventional ammonia or green ammonia or most products that have a properly done LCA done for them.
Lori, you had piqued my interest on, you said that your company invests in new innovations. How do you vet those? And when one comes knocking at your door and is looking for investment, what's that process like?
Well, I think it differs between a difference between products, right? We have a team of agronomy experts and other experts who really vet the opportunities, and you know, sometimes we choose to invest in the business. Sometimes we simply give that business space in what we call our connector, so that farmers can view it and test it out. And sometimes we just, I mean, we have formed partnerships with other organizations to, like our data platform. We've actually formed a partnership with a tech organization that's been building that for us. So we really want to, because we want to innovate, we want to be very flexible about the way we do it, and meeting both the technology and the farmers where they're at.
Is it a pretty quick turnaround?
It can be a very quick turnaround, again, depending on the technology and what the deal is, and you know what the innovation is. I mean, we've invested in everything from technology platforms to new farm inputs to, you know, biologicals and different genetics also.
Back to our participants, are there currently or planned incentives for microbial products such as the TerraPlenish, which can replace up to 60 pounds of nitrogen per acre per season through nitrogen fixation from the atmosphere, but itself does not contain nitrogen? While green ammonia is a huge step in the right direction, the chemical applied at the end of the day is the same and similarly harmful to the environment and other life forms once applied. So does anybody have any working knowledge on whether or not microbials are on the horizon?
Yeah, I mean, I mean, there's certainly activity in the space in terms of development and commercialization of a few different products.
And I would say, just because we produce green ammonia doesn't mean that that's the final form. We can produce other forms, like I mentioned, ammonium nitrate, forms that don't have the necessary the impact that ammonia has on the microflora in the soils.
Brett, I see you've got your mic hot, so was there something you wanted to add?
Yeah, that it's a really interesting world, the biologicals, and to get those life forms to behave themselves and to produce it at predictive rates to create productivity is certainly challenging. And but at the same time, the potential is amazing. I mean, I came from the composting world where the biological components of compost are what adds a lot to the growing capacity of a given soil media. So I really appreciate that comment. And to answer it directly, I'm not aware of any incentives that are currently out there or coming down the pipe that are going to encourage more investment in that area. But that's not to say that there shouldn't be. I think there should be.
There should absolutely be. I mean, we see some of them, and as we search for technology, we see them. And I don't see incentives, right? It's about whether you can get a sponsor interested in it or you can get the marketplace interested in it.
Miguel, maybe we could have you just comment quickly on who should be lining up for these technical service programs, and who are you looking to talk to?
Yeah, thank you, Dan. Like I say, when it comes to certification, we have different options. So I was saying, like, if you feel like you have the qualification or the expertise to develop these management plans, like site-specific nutrient management plan, feed management plans, comprehensive nutrient management plans for landowners and others, it'll be best that you reach out to me so we can explore the different certification options, because we can use your education to get you certified, we can use your experience to get you certified, or if you are one of those individuals that have some kind of a national certification, like if you are a certified crop consultant, if you're a member of the American Society of Agronomy and others, so the list goes on and on. So every case is unique. So I suggest that you reach out to any of us so we can discuss your qualifications. And if you have interest in becoming a certified TSP, we can talk about that in detail.
Very good. We've got one more comment question, and then I'm going to just go around the table quick and have you kind of give me your assessment of what's on the horizon, what you're excited about. Remember, this is the comment question from one of our participants today. Remember that 40% of our corn crop goes to ethanol. That's not feeding the world, but it's feeding our automobiles. So the real question is not how much can we produce, but how efficient we use nitrogen and how cost effective it may be. It may be to use forest and prairie systems, which are better at producing carbon and maybe sustainable carbon fuels for the future. Boy, there was a lot to unpack in that sentence.
Well, I think I'll take a shot at that, since I made the comment feeding the world. First of all, we use more fertilizer, just nitrogen fertilizer, for more than just corn. In fact, if you were to look at that pie chart that I showed, you'd see that nitrogen fertilizer is about 60% of the fossil energy footprint for small grain. So we're talking pasta, bread, some of the grains that are used primarily for food. The second part of that question, 40% might go to ethanol, but of that, a great percentage goes back out for livestock feed. So meat, milk production is also factored in there. So we can't just say that 40% is going to automobiles. That's not true. A lot of that is going back out for feed.
Yeah,
So, but overall though, I think you can see that there's a positive benefit for switching to low carbon intensity nitrogen fertilizer overall. And I don't really see that moving forward in the biomass space.
and the other thing I'd add too is that it's not as if it's being dumped on the ground when it goes into the fuel market. It has, ethanol is used for octane, but at the same time, if we look at it in terms of energy, it still has about 2/3 the carbon footprint of gasoline. So, I mean, we can think about, a future or imagine it was today that we're completely electrified, but that's certainly not the case. And so the use of ethanol reduces the carbon footprint of passenger travel in the United States.
And we've got just well, we're going to go over the end of the runway here a little bit, but I'm going to go around the table real quick. Tell me what excites you about this work, or what you see on the horizon that's coming. And Dave, let's start with you, David Ripplinger.
I couldn't be more excited. I mean, it's real, right? I'm an economist, and so I get excited by different things. So regulation or tax policy that creates the market, the incentives for people to innovate, and in this case, to do innovative things to address climate. It's exciting, and again, you have a lot of the people, and have been involved with this for a while, who are making this future. And again, it's an exciting time, and Minnesota is an exciting place to be for it.
Miguel, what are you excited about?
I'm just gonna talk about, kind of what I do. So, I'm excited to be part of this. I'm excited to be here, like I say, putting out information about the TSP program and, putting these different activities and management plans on your radars. Excited to get folks certified by NRCS and having folks out there that know how to develop these plans, working hand in hand with landowners.
Thank you. Lori?
I'm excited about innovation, and hopefully the tax credits coming up will have the flexibility to support innovation and to foster innovation in all these sectors.
Very good. Anton?
Thank you. I'm excited also about innovations and new solutions that can unlock new pathways for green fertilizer production. And we briefly covered some potential pathways today, but I believe that new solutions are coming in the coming years, and we'll see how efficient they are, not only from the engineering, but also from the economic standpoint. Pretty excited about it.
Mike Reese, other than Morris area, what are you excited about?
Well, I'm excited about the opportunity for farmers to be able to produce their own nitrogen fertilizer, similar to what Landis is doing. I think that not only improves farm profitability, but also helps our rural economies, and anything that we can do to support that, whether it's tax incentives or state policy or federal policy, I'm in favor of.
And Brad, you get the last word today from our panelists.
Yeah, no, thank you, everybody. This has been a great conversation. I think a precursor to a bigger conversation, obviously. But what I'm excited about is this: we're really starting to get serious about a holistic approach to the way that we grow our food and create our energy. And, I saw some additional comments that came in. The advancements that we've made in soil science in the last decade have been amazing, and understanding how organisms work in the soil, and how nitrogen works in the soil. And then, also in a holistic approach, you're also looking at how are we sequestering carbon? How are we building soil organic matter? And there's some neat work being done across the country in this space too, with prairie stripping, and low till agricultural practices and things. And so it's just a really exciting time to see how we're going to make some advances in the next decade or so.
You're spot on, Brad. Thank you. And thanks to everyone who participated today. That does conclude the AURI Connects webinar Wednesday for today. I want to thank Brad Matuska, Dr. David Ripplinger, Dr. Anton Kramer, Miguel Oliveras, Mike Reese, and Lori Marco. AURI Connects webinar Wednesday is presented by the Agricultural Utilization Research Institute of Minnesota and is sponsored by Bremer Bank and Avisen Legal. AURI's mission is to foster long-term economic benefit for Minnesota through value-added agricultural products and processes. We're interested in your feedback, so please respond when we send you our event evaluations. Remember, for more information on today's program or any of the work that AURI is involved with, you can go to auri.org. I also want to remind you that AURI's Minnesota Renewable Energy Roundtable is coming up December 4th in Maple Grove, Minnesota. This year, the topic will include innovations in energy efficiency and industrial heat for the food and egg commodity processing industries. Registration for in-person or virtual is open now at auri.org. Our next Webinar Wednesday will be announced in the new year, so stay tuned for that. And you can always learn more about the work that AURI is involved with by going online at auri.org.